Okay, this homework is the homework set for Unit 5, Lesson 1. This is Day 1 homework. So we started a unit on polynomial functions. And so this comes from question number 1. And we're going to be using a data fitting tool or a curve fitting tool. And I'm going to be using my TI Inspire on one of the school editions here to show you how to do this. So what we're going to do is take a look at application problem 1. Remember, this comes from the Course 3 textbook of the Core Plus Mathematics series, version 2, on page 336. So what we have is we have information about a curve. We're shown a curve, and we have to find data that will is enough data to fit on our curve fitting tool. But we first have to decide what type of graph we're going to make. Will this be quadratic, cubic, or quartic, or some other type of function? Since we're studying polynomials, we'll probably stick to those first three: quadratic, cubic, or quartic. Quadratic, of course, being x squared models, cubic using the third degree, x to the third, and quartic being the fourth degree, x to the fourth. So we're starting with question number 1 here, and again with the curve of the video here, you might not be able to see it very well, but I'm going to pop this up a little bit. What we're seeing this quadratic curve, and I think it's quadratic because this to me looks exactly like a parabola would. I also noticed this: there's only one maximum point. In class, we looked at how there's a pattern that shows like a degree 2 polynomial can have at most one maximum point. For instance, on B, we have one max and one minimum point having 2 total max and mins. So this is probably a degree 3. And then this one has 2 maximum points and 1 minimum point. Again, those are local. Although these maximum points are probably absolutes, we don't see the rest of the graph, but I think we can assume that those are absolutes. Locally, though, those are 3 max and mins, which means this could be a degree 4 or a quartic. And then lastly, this curve here, although it looks kind of like a parabola, it has this kind of weird leveling out motion over here. And it doesn't quite level out. There's definitely a lowest point still in the direct middle. But this is probably not quadratic since it doesn't look like a parabola. We'll probably call that a quartic model. So what we're going to do is we have to find enough data and then report the modeling function using the data we have. So I'm going to start with A here, and A is quadratic. So to do a quadratic, we know it's going to turn out an equation that looks like y equals ax to the third plus bx, whoops, I said quadratic, so this is ax squared plus bx plus c. Or in standard polynomial form, I'm looking at something that looks like y equals a sub 2 x squared plus a sub 1 x plus a sub 0. Either way, I've got 3 things to find, so I need to have 3 points. 3 points. So I get to read my graph and discover what those points are. I really like how the point 0, 2 shows up, so I'm going to use 0, 2. I'm going to take a look at using 2, 8. Those intersect nicely. And then if I keep looking, there's another one at 4, 6 that I really like, so I'm going to use 4, 6. You can use other points, but these are the 3 that I'm going to use. I'm now going to put these into my graphing calculator as an option here. So what I'm going to do is I'm going to go right to a new menu. I'm going to hit the home screen button, and I'm going to go down to the section that says add lists and spreadsheet. So I'm going to do that. And underneath A, I'm going to put all of my x values. So 0 is going in, 2 is going in, and 4 is going in. And then in B, I'm going to put the corresponding y values, 2, 8, and 6. Now what we're going to do is we're going to find the appropriate quadratic by going to Menu, Statistics, Stat Calculations, going to Quadratic Regression, number 6. Now up here in XList, I want to make sure that that matches what I put in. I put it in list A, so I'm going to use list A. My Y list was in B, so I'll hit B. And I also want those little brackets that are there. The brackets represent using all the data in that column. The brackets are located above the parentheses, so I'll bracket that. And note it's going to save to F1, so I can check my curve when I'm done. The frequency stays at 1. And then I'm going to check one more thing. The first column results are going to show up in column D. That's fine. I could also call column C if I wanted to, but D is okay. Say OK, and there it is. The title is Quadratic Regression, and I see that I have ax squared plus bx plus c, much like my expression on the left there. And then I have values. A is -1, b is 5, c is 2. So I'm going to write out the expression as it shows up. So this turns into y equals a negative x squared, -1 really, but I don't have to write the 1. 1 times the number just gives me the number out. So I can write this as negative x squared plus 5x plus 2. Now I'm going to verify and make sure that this matches. So I'm going to go ahead and add a page, and the plus page is above document here. So I'm going to add that page. It's going to ask me what I want. I would like a graph. That's number 2. Now note it starts with F2. The subtlety here is that F1 is stored the equation I have for my quadratic, and it's already interested in there. So I'm going to hit enter. And there's my curve. And I might look and say, okay, does this look the same? My first action is no, it doesn't. But then I remember that, wait a minute, I don't have the same viewing window. This is on a standard window on the calculator, but in the book we have a window that's been modified. So I'm going to modify my window to match what the book has. So I'm going to do that by going to Window Zoom, Window Settings, and then my X minimum, here it looks like it's at -1. The X maximum goes all the way up to +6, and the scale here is by ones. My Y minimum, lowest Y value is a -6. My Y maximum goes to a +10, and it looks like the scale here is up by 2s, 2, 4, 6, 8, 10. So we'll make the scale a 2. I'll hit OK, and now we're looking pretty much the same. Okay, and just to verify, I could do a graph trace as well. I go to Menu, Trace, Graph Trace, and then put in some values that interest me. Remember I put in 0, 2, so maybe I'll hit 0. Sure, 0, 2 is there. I can put in 2 and see if 8 shows up. Sure enough, it's on there. I hit 4, 4, 6. So it fits the 3 points I chose perfectly. All right, and that's how we do the quadratic curve. Let's go on to the second problem. The second problem, again, I mentioned earlier that these it has 2 mins and maxes, so I think this is going to be a cubic curve. So what I'm going to do for a cubic curve is I remember that this is really ax to the third plus bx squared plus cx plus d, or using standard notation, a sub 3x to the third plus a sub 2 x squared plus a sub 1x plus a sub 0. I need to come up with enough points to find all of those missing coefficients, a, b, c, and d. So I'm going to need 4 points for this. So I'm looking at the curve again. There's a beautiful point at 0, 0. I've got another one at 2, 0. A third one at 5, 0. And it's okay to use all the zeros, but I do want to use one more perhaps that's not a 0. So to find one that's a good approximation. This one's a little bit more challenging because none of the points seem to cross as nicely as the other ones did. So here's where our answers may vary a little bit in how we take these. But I might choose to do something like, let's put in 1. At 1, we cross over here at something that looks like 4. So I'm going to put 1, 4 in and see how that goes. All right, so I'm going to put those points in the calculator as well. Now I can bring up the same menu I have. I'm just going to go back to the tab that had my data in it, and I'm going to add another point. I'm going to put that point down here in the 4th row. I have to change all of them though. So I'm going to go back up here, make 0, 0. My second point was 2, 0. The third point I chose was 5, 0. And then my fourth point that I chose was 1, 4. Oops. That just gave me an error because I hit enter before I gave it a corresponding value. All right, now this data over here, the quadratic stuff, it changed with the data, right? So this now fits a quadratic curve to that, but I don't want the quadratic curve anymore. I want a cubic curve. So I'm going to go to Menu, down to Statistics, Stat Calculations, Cubic Regression, that's number 7. And I'm going to tell it again where my data is. So my X list data is in A, my Y list data is in B, and this time it's going to save my equation to F2, that's fine. And we're going to put the data in, it says to put in E, but you know what? I'm going to put that in D, so it overwrites the old stuff. So I'm going to put it in D with the column marker, and it's going to say, it's going to overwrite my data. And I say, yep, that's okay. So here's my new overwritten data, and it looks like I have my equation with A is 1, B is a -7, C is 10, and then D reads -1.8, E -12. Well, remember that's scientific notation in the calculator for -1.8 times 10 to the -12. That means that this decimal point would have to be moved 12 places to the left, essentially making this 1.8 with 11 zeros in front of it. That's pretty close to 0, so I'm going to allow D to be 0 here. So I'm going to write out my expression right here. Y equals, the 1 I don't have to rewrite, but I'll write x cubed minus 7x squared plus 10x, and again, I'm not going to add that 0. I do want to verify, though, if my curve is correct, so I'm going to go back to my graph now. So I'm going to hit tab over, And this is the curve that it fit with the quadratic originally. So I want to take that off. Okay, I don't need to see that. That was F1. And what I do want to do, however, is see what F2 was. And so I want to, oh, looks like I go back. I scrolled down to 99 there, so let's get this all the way back up to F2. Sorry about that. There's F2. And there's my curve. Now again, I'm not sure if that matches the way I want it to, but if I hit the menu and I go to the window, I can then change the window settings to match. And again, the -1 to 6 is still the same, but my y's are different. Now I go down to a -20, and I go up to a value of 15, and my scale is 5. And doing that, now I have a graph that I'm pretty happy with matching here. And again, I could verify the points are on there, but I'm going to let that one go and try part C. Part C, I'm looking at this shape now that has 1 maximum, 2 maximum, and 1 minimum. So I have 3 mins and maxes. I think this is going to be a quartic. So if I write out the quartic equation, ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e, or again, the standard form of this would be a sub 4x to the 4th plus a sub 3x to the 3rd plus a sub 2x squared plus a sub 1x plus a sub 0. Now I'm going to find that I need enough points to cover A, B, C, D, and E, so I'm going to need 5 points this time. So we're going to find 5 coordinates. So we go back to the curve, and I'll look for some nice ones. There's 0, 0. That shows up nicely. 2, 0 shows up nicely. 4, 0 shows up nicely. And now I need 2 more points. Generally speaking, I like to go with the maximums, but there's a nicer value if I look at 1, 15. That's on there really nicely. And then again, I have 3, 15, very symmetric. So I'm going to use those 5 points. I can just go back again to the tab with my data in it. I'm going to add points onto this. So I need to change the ones I have already. Although 0, 0 is still in there, 2 zeros in there. I'm going to change this one to a 4, 0. And then I'll let this last one be 1, 15. And then I need to put 3, 15 in there. And again, it's going to give me the error that I need to have full points in there. I get that, so I'll make this 3, 15. And I want to now do a quartic regression. So menu, statistics, stat calculations, quartic regression. And my data in X is, again, it's A. Data in Y is B. It's going to store as F1, which is great. I want that. And it's going to put it in D. So I say, OK, no problem. And it overwrites my current. I say yes. And look at those nice values. A is -5, B is 40, C is a -100, D is 80, and E is this -1.5 times 10 to the -12. So again, essentially 0. So we'll let that be 0. Write out my equation. Y equals -5 x to the 4th plus 40x to the 3rd minus 100x squared plus 80x, and then plus 0. Of course, I don't need to put that. So there's my equation, and I could again verify that, checking the graph, and this curve is still F2 from last time. So we're going to take F2 out, and we want to look at F1. Okay, hit enter on that. And this curve should fit. And again, F2 is still on there, so if I want F2 to go away, I need to clear that and hit enter. Okay, that's gone now. I should match the graph up. I need to go all the way up to 20, it looks like, so I need to change the maximum of my curve. And looks good. All right, last one. So we have to look at D. Now D is at the top of the page there. D, again, I said earlier, it only has 1 minimum. So like, oh, quadratic, but it's not. The bottom of this definitely doesn't look like a parabola. So we're going to take enough data to do a quadratic, or excuse me, a cubic like we did in the previous expression. So we have y equals ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e. And again, I have that same standard notation. I need 5 points So these points, a little bit more challenging. I'm going to let negative 4, 0 go in. That's this one, looks pretty good. I'm going to let 1, maybe negative 5. And since I'm going symmetric, maybe I'll let this value over here, 2, negative 5 go in. And then I want some other values here. Whoops, I put this backwards. This doesn't negative 4, 0. This was 0, negative 4. Okay, and if I look, there's a negative 4 at 3 as well. So we'll put in 3, negative 4. And then maybe we want one more value. Let's see, this one maybe at the 0 there. That's between 3 and 4. So it's almost 3.5. So maybe I'll put in 3.5, 0, and see how that goes. Okay, and so I'm going to go back to my data section. Oops, I hit a button there. Back to the data section and put in those new points. 1, negative 5. Okay, now it keeps telling me weird things about singular matrix. It's because I have to fix the data. So if you get that error, you don't have to worry about the error. Or you can always do this too, hit Control-N, and just set up a new document. That works out well too, stats and spreadsheet. And then we can just put in the data again. 1, 2, 3, 3.5, and I forgot the 0, so we'll put 0 on the bottom. And then for 1, the corresponding was a negative 5. For 2, I also have a negative 5. For 3, I have a negative 4. For 3.5, I have 0. And for 0, I have a negative 4. Menu, statistics, calculate, quartic regression, and my X list is in A. My Y list is in B. Okay, whoops. Oh, I canceled out of that by accident. So menu, statistics, stat calculations, quartic regression. Data is in A, B, source to F1, and it'll put in C. Great. Now this value looks pretty terrible right here in terms of values to put in, but I'm going to go ahead and write those down and see what comes out. So y equals 0.476 x to the 4th minus 2.857 x to the 3rd plus 5.738 x squared minus 4.35 x minus 4. And let's see what this looks like. Okay, so I'm going to add a page, add graphs, and see if this is anywhere close. So this is my data. And you can see that at the bottom of this, it doesn't match what I see in the actual curve up here. This is flat. This one definitely does not look like that. So the curve fitting tool has a harder time with this based on the data I chose. I'm going to keep this one. It's not a perfect fit, but we're going to be okay with that. So there you go. There is day 1 homework for Unit 5, Lesson 1.